Example 3z. The height of a firework is modelled by the equation h of t equal to at squared plus 5t, where the h of t is the height of the firework and a has to be greater than 0. Part A of this says to factorise the function and thus determine when, in terms of a, it would land on the ground, i.e. when is h of t equal to 0. Graphically, this looks like an upside down parabola where we know what the 0 part is. This is where our rocket takes off, or sorry, our firework takes off. We want to know when does it land, so the t value for this part here in terms of a. So in order to do this, we can recognise the fact that h of t is a quadratic with x-axis intercepts. So if we take our h of t formula and we determine the x-axis intercepts, we can actually calculate t. Now we would expect that one of these will be 0, because that is our origin where we start, but we're after this one here. So we'll take h of t, make it equal to 0, and then factorise it. So pulling out t as a common factor, and then we can apply the null factor law. Straight off the bat we get t equals 0, which is our expected origin, which is brilliant, good. And then we make at plus 5 equal to 0, and we solve for t, giving us a value of t equal to -5 on a. So it, in terms of a, would land on the ground after -5 on a seconds. Part B says to make the equation equal to d, and then solve for t in terms of a and d. So first step, make our h of t equal to d, and then rearrange it. So at squared plus 5t minus d. We are now in a quadratic form, which we can use to solve. Now we don't have numbers for a and d, so our best way to solve this is to use our quadratic formula. So if we apply the quadratic formula to this, where a is equal to a, b is equal to 5, and c is equal to -d, we are not going to get out a nice simple answer. We will get out something that's quite horrible, and that's fine. So we'll get out a result of t equal to -5 plus or minus the square root of 25 plus 4ad divided by 2a, and that is our solution to this quadratic equation. Please don't try to take the 25 and square root it, or the 4 and square root it. We have a plus in the middle, so this cannot be simplified any further than this. Okay, Part C asks us to use the discriminant from Part B, and then calculate what value A must take in terms of D for the height to be only reached once, i.e. for a height to be only reached once, the discriminant must be equal to 0. So we take our discriminant of 25 plus 4ad and make it equal to 0, and we solve for a. So the value of a in terms of d is -25 on 4d.